Okay, welcome to part 4 of Multidimensional Essentials, where we're looking at energetic architecture. So we've looked at the 4 dimensions, 0, 1, 2, and 3, and we've looked at the very shape of space, how space is shaped necessarily, inevitably, the only possible way it can be in those 4 dimensions. And now this is where the rubber hits the road. This is where we start to see these things actually in our life. Because look, if these are the 5 shapes that define space and define everything that exists within that space, then we ought to see it showing up in reality around us, right? And so do we see evidence of that? I sure hope so. Oh, skip right to that slide, huh? Okay. So we're starting with the fact that Plato himself assigned elements to shapes, right? So there are 5 great elements: ether, air, fire, water, earth. There are 5 platonic solids. And isn't it interesting that Ayurveda, which is the most ancient system of natural philosophy that we still know about on earth, said that everything in all of creation is composed of some combination of these 5 elements, some ratio of them. And then geometrically, it's unavoidable that there are these 5 shapes which define the structure of space itself. And so Plato was a clever guy. He figured out that maybe there's a correlation between these things, and these are the correlates that he gave. And so here's then my diagram associating them with chakras, just through elemental association. And so this gets really interesting when we then also think about the paired opposites, right? So if the cube and the octahedron are opposites, that means earth and air are a paired opposite. And great, earth, the most dense, solid thing; air, the movable, the only element that has the quality of mobility. So we've got something solid, something that moves, the most dense thing and the most movable thing. And if the dodecahedron and the icosahedron are paired opposites, then that means water and ether are a pair. And isn't the bottom of the ocean so similar to outer space? Like, if you look at footage from deep, deep ocean, it's dark, it's super dense, and there's some monsters swimming around, with their little light bulbs. And you look out in deep space, it's dark, it's super dense, packed with ether. This is one of the things that Ayurveda and Samkhya says, again, contrary to popular opinion, that space is not empty. Outer space is not an empty vacuum. It is actually packed densely full with what we call ether, the stuff of space. And so we think about this where sound waves travel through air, water waves travel through water. We see plate tectonics, mountains are like waves traveling through earth. But what does light travel through? What are light waves traveling through? And then the answer is ether. This is a controversial thing for sure, but we'll see. There's some, Nikola Tesla agrees, Einstein agrees. We've got good backing on the side of ether. So anyway, coming back to the similarities between ether and water, and we'll see in just a moment how similar those two things are. And then fire is the tetrahedron, which is its own opposite. And isn't that just so? Because fire is fire is fire. It doesn't really matter what the fuel is. If you've got a campfire, you can throw wood or brush or beer boxes or clothes or whatever you've got on there, and the fire remains fire. Everything it touches is transformed, but the fire is the fire. And so the tetrahedron is its own opposite. It's just this little engine just churning tetra, 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 right? Back and forth, back and forth. So that we can sort of make intuitive sense of these correlations, where most great cities are organized around a central square, aren't they? Square creates a cube, earth element. And if you think of like, a square, and then there's usually like the parliament buildings or whatever, that's actually creating a cubical space. And this is the earth element around which great civilizations have based themselves. The icosahedron has the softest external angles, right? It's the most round of the 5 platonic solids. So it's the most spherical. And if you think of water, it's got that sort of flowing nature, something, water is sweet and soft and these sorts of things. And so the icosahedron has most of those qualities. Whereas the tetrahedron is the sharpest. It has the sharpest angles and is pointy. And so if you think of like eating something spicy, something fiery, it's almost like as there's a bunch of tetrahedrons stabbing the inside of your mouth. It's one way to think about it. Whereas if you're eating something that's sweet and like watery and smooth, you've got more like spherical icosahedrons flowing around, right? That's one of these sort of intuitive ways to imagine it. The air element is the octahedron, which is perfectly balanced above and below. And it has some pretty sharp angles as well, right? It's not as sharp as the tetrahedron, but pretty sharp. And air is drying, right? You hang your laundry up in the wind, and the wind comes through and cuts away the moisture, right? And wind will also burn you, right? So it's like similar to fire in that way. So it's got that sharpness to it. And I love that the air element is also associated with the heart chakra. And that for me makes sense, where the octahedron is perfectly balanced, right? Above and below. There's a downward pyramid and an upward pyramid, and that's that heart center space. And then the dodecahedron as ether, it's like the pentagon is unique amongst the shapes, right? And sure, you can make a pentagon out of 5 triangles, but I think it's really interesting that air, water, fire are sort of the most dynamic elements. They're the primary elements that we're dealing with on a daily basis, right? There's the wind, there's the sun, and we need to drink water, right? These are the things that constitute life. And those 3 are all made of triangles. And so you can think of the interaction of these elements as just like, it's just a bunch of triangles exchanging with each other. Triangles bouncing off triangles, and this type of triangle hitting that triangle and sending a new triangle over there and just reforming. And then ultimately, like, this is what chemistry is, right? This is what chemical interactions are. Like, oh, cool, I've got this many triangles. Here, you have one, and I'm going to take that one. And like, that's what chemistry is, right? So this is this sort of like very like metaphorical explanation for the metaphysical qualities of what's happening in chemical and physical interactions. Whereas ether doesn't really interact. Ether is actually the container for all of this. And so it doesn't really exchange. Ether's not giving out triangles or taking any back. It's got pentagons. It doesn't have triangles. It's got pentagons. And so it's not really interacting. And then the cube, again, like, you can make a cube out of triangles, but they're all fixed together. They're a little more fixed together, right? You have to fuse triangles together in order to create a square to then create a cube. So it's interacting less. And Earth gives us that structure. Ether gives us the space in which it's all happening. And then air, fire, water are doing the dance, exchanging, playing, and dynamic in between. Yeah, does that more or less make sense? Cool. So yeah, there's a certain amount of satisfying sense making we can do there. And this understanding, when I learned that Plato himself had assigned the shape, the Platonic solids to specific elements, that was where a little bell went off. And I was like, oh, if we're trying to figure out how Ayurveda, the elements of Ayurveda and the elements of the periodic table can communicate, maybe the Platonic solids are the Rosetta Stone. And that led me to a gentleman named Dr. Robert J. Moon. And so he's an advocate of the ether theory, right? According to the accepted theory, free space is a vacuum. If this is so, how can it exhibit impedance? Which like, it just shows that outer space has physical qualities. Like, things don't flow perfectly smoothly through outer space. There's some measure of impedance. And the answer, of course, is that there is no such thing as a vacuum. And what we call free space has structure. We are no longer able to talk about empty space. And I am willing to listen to Dr. Robert J. Moon because he taught physical chemistry at the University of Chicago and was one of the key players in the Manhattan Project during World War II. Like, he was one of the guys, Manhattan Project is famous for its segmentation, where people were working on crazy stuff, but didn't know it was just their little part. And then they sent it higher up and then it all came together. Moon was one of the guys who knew what they were doing and synthesized all of it and told other people what to do. So later in his life, quite naturally, he regretted his role in what turned out to be a horribly destructive enterprise. And he turned his attention to more generative, life-affirming pursuits. And in the attempt to create a viable model for the structure of the atomic nucleus, which is something that remains mysterious. There's still debate because it's the atomic nucleus. Still don't know quite how to structure it, right? It's where we get into quantum physics, and it's not clear how it's actually structured. And so he wondered if atomic structures might be organized according to the Platonic solids. And so what is now known as the Moon model proposes a symmetrical arrangement of charges or protons on a sphere surrounded by a set of nested shells and orbitals, which are electrons, beyond the nucleus. We're going to, the verbal explanation of this is tough, but we're going to get in there. So for example, in Moon's Keplerian atom, named after Johannes Kepler, who we'll talk about next, the 92 protons of the naturally occurring elements of the periodic table are determined by the vertices of two identical pairs of nested Platonic solids, each containing 46 vertices. So that's the summary statement. Basically, and we're gonna look at some images in a moment, but basically the atom is defined by protons at the vertices of Platonic solids, and everything organizes itself around that. So let's look at what that actually means. So this is an image of, we've seen this before, right? The nested Platonic solids. There's a cube in the middle with its octahedron around it. The octahedron actually fits quite cozily into the icosahedron, and then there's a big dodecahedron around it. And this is the working model of the four nested solids for the Moon model. And the secret magic of this is that in that stack of four solids, adding them all together, they have 46 vertices. Cube plus octahedron plus icosahedron plus dodecahedron, add all their vertices together, you get 46. And then if you were to take that stack and add a second stack next to it, 46 plus 46 is 92. There are 92 elements on the periodic table.
Yes.
Yeah.
How does this account for an element that doesn't have, that's like 91?
Right. And so there's like, we'll look at that, but basically these provide the structures, and then you can combine them in different ways. And of course, not everything is a perfect Platonic solid, because looking at, like, there are atoms that are super reactive, right? And so it's unstable. It's not a perfect Platonic solid. It's an unstable element. And so it doesn't hold its structure very well. And so it's based here, but then it's got some like loose wing on it.
So would it be
That
like
makes sense.
the noble elements actually do have like
You're on it. You're asking absolutely the correct questions. So here on the left, we see the first shell proposed by Moon is a cube, which reflects the distribution of 8 protons in the nucleus of oxygen. Now, oxygen is one of the most, I think is the most prevalent element in on Earth. We'll get to that in my notes. Again, not a big science guy. Math, math not my strong suit. Myth and metaphor, right? And so this is right at the edge of I wish I could go back to AP chemistry with this information. And so the perpetual plug is, if you are or know a nuclear physicist or some sort of amazing biochemist, please put them in touch. Please show them this information. Please, like, there's more research to be done, because this is where Ayurveda and modern biomedicine and physics and chemistry join. And I can imagine that if we knew how to do it, we could make really customized medicines. We could organize pharmaceuticals in a way that were actually like in alignment with biochemistry, as opposed to super harsh on it. There's a bunch of potentials here that are way outside my personal scope of practice here. So just collecting the data points and smashing them together for you. Okay, let's keep reading, because that's where I'm safe. The next shell would form after adding 6 new protons, reflecting the distribution of the 14 protons in the nucleus of silicon. With 6 new protons, we now have an octahedron with the cube inside it, seen right here. If you look at it carefully, right, you can see the dotted lines that are the cube, and then the octahedron around it. Yeah. The layers keep building like this, filling out the next sequential shell until every vertex is full and its capacity to contain protons is complete. So then the next proton starts a new layer and a new geometric shape, right? So the idea is, okay, we've got 8 protons in a cube, and then again, like whatever the element is with 9 protons is the first point in the octahedron, and then 10, and it starts to build the octahedron around it. And so this is like, I remember from chemistry, valence shells, right? And there are these different organizations where the one has a certain number, and then the next one out can hold a certain number of, I think valence shells talk about electrons, but same principle. And it's these concentric layers of charges. So there's this deep alignment with what we already know in chemistry, but to organize it using the platonic solids as the key is something that Moon brought forth, which never been looked at before, and is actually revolutionary. Let's see, when we get to 46 protons, that's palladium. The next proton initiates the start of a new shell altogether, building again until we have a bonded pair of 46 protons for 92 altogether, which makes uranium the last of the naturally occurring elements. So using the 5 platonic solids inscribed within nested spheres, we can create every single naturally occurring element. And so this is a representation of the pairing process between 2 dodecahedra. So you can imagine that there's all the nested solids within those dodecahedra, or they're just 2 dodecahedra linking, and the varying levels of stability are shown by these geometric structures, and it indicates the varying stability of the elements themselves, right? So these twin dodecahedra are joined at a side, so there's 2 pentagons that are smashed together. And this is radon number 86 when joined at a face. And radon well, uranium is observably more unstable than radon. It's not super stable, but relative to uranium, radon is super solid. It's got that face joined. Whereas to build number 91, protractinium, we are down to just one point of connection, one vertex barely hanging on. That's number 91. And that is super unstable, highly reactive with oxygen. It's highly reactive with oxygen, water vapor, and inorganic acids. So protactinium just wants to explode and wants to burst apart, wants to fly apart, because it's these two big shapes connected to just this one, it's a broken hinge. Yeah.
I'm a little confused as to where we're getting these two separate orbs.
Yeah.
I thought we were talking about stacking inside.
Yeah. So we stack inside until the last outer layer is the dodecahedron. And then when there's another proton beyond that, we start stacking again.
Gotcha.
And then when we've built the other one up so that it's got the external layer of the dodecahedron,
Gotcha.
then they're linked.
Gotcha.
That makes sense?
Yes. And so if this middle one's uranium, you just like add a little heat to it, and that's what creates nuclear fission.
Yeah.
So those two break apart, maybe.
Yeah.
I don't know.
Yeah, so something like that. Dr. Moon knew, but he died shortly after this. He was doing this in like the early 80s, and he died in 1986, which is just really, really too bad.
Do we know for sure that there's only 92 elements?
92 naturally occurring elements.
And are scientists sure that that's it, or are they open to discovering new ones?
I mean, Iron Man discovered a new one, so it's always possible. But if you watch that scene when Iron Man discovers a new element, it's full of platonic solids.
Sure.
It's actually all platonic solids merging together into a vector equilibrium is what it does. So I don't fully know the answer to that question. It's a good question. I would suggest that based on the moon model, it's complete. Unless you can add a third, right? Add a third set of dodecahedra in there, because interesting, to make a dodecahedron, it's 3 pentagons that come together. So I wonder if it's possible to merge a third dodecahedron into this bonded pair. Anyway, that's actually some multidimensional work. That might actually be, we might not be evolved enough to get that yet. And that's where, like, okay, we've talked about the third dimension, like what does the fourth dimension look like or consist of? And we're going to talk a little bit about that tomorrow, but just like, there's a great book, what is it? Flatland. You guys ever heard of Flatland? Oh, it's wonderful. And it's a social allegory, which is very beautiful, it's a very feminist book in a lot of ways. But it's all about a 2-dimensional world where like rank and status is defined by what shape you are. But if you're in a 2-dimensional world, it's hard to tell the difference between, are you a triangle? If I'm looking at you from 2 dimensions and I just see a flat side, are you a triangle or a square? It's hard to tell. And so it's all about this. And the reason I'm pointing that out is that from that level, it's really hard to imagine up or down. Like from that level of awareness, conceiving of up and having an overhead view is like inconceivable. And so that's sort of the relation of the third dimension with higher dimensions, is how I would understand.
Just a different size of a line.
Right. It's just a different size of a line. And as the shape is twisting, the line becomes a different size, right? Where a triangle goes from a line to a point. Like, whoa. So it's a great book. And I think there's a cartoon series that was based on it as well. Worth looking at. Okay. So here's our sort of like simplest breakdown and correlation. And again, getting really excited that we know the cube is associated with, in Ayurveda, the earth element. We also know the cube is associated with oxygen. So looking at those first three, oxygen, silicon, and iron correspond to the elements that seem to be of greatest abundance in the solar system. Super stable oxygen, associated with the earth element, composes 62.55% of the Earth's crust. Oxygen is also an essential change agent in chemical reactions. Silicon is the next most abundant element in the solar system, making up 21.22% of the Earth's crust. Silicon is a vital conductor of electrical charge, and the air element is very much associated with electrical energy. The air element is associated with the nervous system, and which is basically like a big electrical circuit. And so that one's super satisfying. Silicon is a great conductor of electricity. Air element, very much this electrical quality to it. And that's our oxygen plus cube plus octahedron. And then iron makes up only 1.2% of the crust, but is the fourth most significant by weight. Iron makes up 5% of the Earth's crust by weight, which is 3 orders of magnitude greater than the elements near it in the periodic table. So iron is famous for its capacity to establish and maintain a magnetic field. So right here in these first 3, we've got electricity and magnetism sorted right out. And electricity and magnetism are inseparable energy forces, but they arise at perpendicular angles. Again, we're going to talk about that more in part 7. So iron is also an important component of hemoglobin, which carries oxygen through the body and helps plants with chlorophyll production, which are both core functions of life. So the water element carrying oxygen through the body, water element, core component of blood. What is blood except red water, basically, right? Iron rusts and turns red. And in plants, instead of turning red, it turns green. And because it's doing photosynthesis, it's basically just the inverse process. And so then we have, for the dodecahedron, we have palladium, which is a uniquely symmetrical element that represents an important boundary condition in nuclear fission. So exactly what you're saying, like you put 2 particles of palladium together and you end up, it's a boundary condition. Again, this is like right on the edge of my understanding of chemistry. So chemists out there, please get in here. Please get in the comments. Please support, confirm or deny. But I'm just listening to Dr. Moon, and I trust him. Okay. There's some other singularities that the Moon model identifies as important along the way, but we're not going to go into that. Yes. My statement is that further research is needed on the significance of these elements. If anyone is or knows a nuclear physicist or biochemist looking for a fun project, please put us in touch. Now, in all of this, you may notice the conspicuous absence of the tetrahedron. Where's the tetrahedron in all this? What's happening? Why don't we have a tetrahedron? But we've said tetrahedron has special properties, doesn't it? It is unique amongst the 5 platonic solids. And sure enough, Moon assigns special status to the shape that represents the simplest way to enclose volume. He calls the tetrahedron the alpha particle, whose vertices first serve as the 2 protons and 2 neutrons of a helium nucleus. While for the nuclei of atomic number greater than 2, this inner tetrahedron would serve as the location for neutrons. The shape that is its own opposite pair serves as the location for neutrons. There's something elegant about that, isn't there? Where at the very core of the whole thing is the tetrahedron, just, flipping back and forth, being sort of self-referential, self-stable. It's a neutron, right? It's self-neutralizing. And the other thing that Moon did, and this is this image on the right here, is he suggested a restructuring of the periodic table organized into a tetrahedron. So that's what we're looking at there, is he's basically taken the periodic table of elements and reorganized it so that it's structured within that three-dimensional shape. And this, again, is a little bit beyond my pay grade, but all the papers that I've read about it that I can't repeat to you here are like, yeah, this makes a ton more sense. It's elegant, it's clean, it like packs it all together in just the right way. And so it's this reorganization of the whole periodic table according to their relationships as defined by the Platonic solids. So this is the outcome of that master's thesis, looking at the periodic table of Ayurvedic elements. And can we put these things together? Yes, we can. The Platonic solids are the Rosetta Stone, and there's more chemistry than I know how to do, but theoretically, metaphorically, it works, and there's really good science behind it. And so more research needed. Maybe next I'll go for my PhD in organic chemistry. Yeah, we'll see about that.